Manual laser welding. In metallurgy, all the time complex shapes are being made. The easiest and fastest way to cope with such tasks is to join together basic details. This technology is extremely common, and of course, it has a name. The process of joining different metal parts is called welding, and there's a fairly large number of welding methods. All of them have one thing in common. The welded parts are connected through atomic bonding. The welding method you see on the screen right now is known as manual laser welding. When using this method, the heat source that causes the atomic bonding is a laser. This process is most widely used to create radio electronics and other various electronic equipment. With the help of the laser, both the same and different metals can be welded. In this case, for example, stainless steel is being produced. Note that the metal parts are quite large, about 1 meter in length. The thickness of the parts is 2 millimeters. The amazing power of the laser, as much as 400 watts, joins them in such a way that it's impossible to separate the parts after they've cooled down without tools or brute force. Micro welding. And here is another welding method. Its distinguishing feature is the reduced beam diameter, which makes it possible to work with even the smallest details. The principle of operation, however, remains the same. It can be described as follows. Special equipment creates laser radiation, which is then focused into a beam. When it hits the parts to be welded, part of the beam is reflected and the other part penetrates the metal. Heat absorption causes the metal to heat up and then melt. This is how the weld is formed. The special feature of this welding equipment is that the beam diameter can be adjusted. Thus, the scope of its application is significantly expanded. Interestingly, laser welding is even used by jewelers. With its help, for example, it's possible to change the size of a ring or reattach a broken nose pad to a pair of glasses. And here's a special welding machine designed for repairing molds. It differs from the models used in the metallurgical industry in that it has no computer numerical control. This means that the equipment is aimed at individual work, not mass production. Also, the laser operator needs skills and precision. TIG welding. As we've already said, there are a huge number of welding techniques. They all differ from each other, but we'd like very much to highlight a method known as tungsten inert gas welding. This welding method is used when it's necessary to get a high-quality weld. However, there are also disadvantages to TIG welding. The welder is required to be highly qualified. Also, productivity is significantly reduced compared to other types of welding, but let's talk about the process. The main tool is a tungsten electrode. It can be used to weld almost any metal or alloy, including low-carbon and high alloys. To ensure precision, the electrode is ground periodically. The equipment supplies an inert gas such as argon in a circumference. When air enters the welding area, hydrogen is released, resulting in a porous seam. Argon shields the welding area from the air, ensuring a high-quality weld. Metal 3D printing. Although welding is a very interesting process, we'd like to show other areas of the metallurgical industry in this video. Additive manufacturing, or in other words, 3D printing, is one of the most actively developing technologies in the world today. And it's not surprising that it's also reached the metal industry. Metal 3D printing is also gaining momentum. The reason for this is that printed metal products have better performance when compared to products created in traditional ways. Besides, metal 3D printing is a cost-effective technological process. The waste is minimal, while the production is, on the contrary, maximized. Besides, additive manufacturing requires less manpower. Also, the printed products often have smaller weight than those manufactured traditionally, thus reducing the weights of complex structures. Hot dip galvanization. Metal is a durable material, but it has one weakness: corrosion, also known as rusting. It is the gradual destruction of metals by a chemical reaction with their environment. A way to fight corrosion and slow down its destruction was first described in 1742. The patent for galvanization, i.e. applying a protective zinc coating to iron, was issued back in 1836. Since then, this method of metal processing has not lost its importance. Pre-cleaned parts are lowered into special baths filled with zinc heated to 450 degrees Celsius. The atmospheric impact makes the pure zinc react with oxygen. First, zinc oxide is formed, and then zinc carbonate. It is a grey, hard material that stops metal corrosion. Hot dip galvanization is the most common type of coating in the metallurgical industry. Its unsurpassed demand is explained by reliability and economic benefits. Studies have shown that zinc protects the metal from rusting for a period of 65 to 120 years, depending on the aggressiveness of the environment. The thickness of the zinc layer covering the metal part can vary from 30 to 100 micrometers. Metal cutting. Finally, we're going to show you another very common method to process metal. Cutting metal has been the backbone of the metallurgical industry from the moment people began to process metal at all. Of course, today there are a huge number of cutting tools as well as cutting methods. We'd like to talk about turning and milling, as they are quite easily confused. So, metal cutting is referred as turning if the cutting tool is fixed. The processing is done by the contact between the cutting tool and the rotating metal workpiece at high speed. It's noteworthy that the work can be done with both the outer and inner surfaces of the workpiece. It's also worth noting that turning is one of the most ancient technological operations invented by man. What you see on the screen is just the automation of an ancient process. The point of the process is to remove the unnecessary layer of metal until the workpiece looks right. When we talk about milling, the first thing we need to say is that the cutter is a rotating tool. That is, in this case, the workpiece remains in place and is treated by a sharp rotating cutter. The patent for the first milling machine in history was issued in 1818.